Hi everyone, this is James, and this is a new version of the Creating a Drivable Vehicle in Unity. And this tutorial resolves a lot of the old weird issues with the wheel colliders and wheel alignment and strange things in the original Creating a Drivable Vehicle in Unity tutorial. This tutorial is basically geared towards mobile optimized platforms like iOS and Android and stuff like that. The script is simplified and the car is way simplified. It has no wheel colliders or anything complex like that. It's just a simple box collider with a rigid body on it. So about as low as you can get for physics calculations. You can't use any less than this for the physics of a car. And so, needless to say, it's pretty optimal for running on phones and tablets and stuff like that. And it also doesn't deal with all those crazy wonky issues with wheel colliders and alignment and stuff like that. So at the sacrifice of you don't get pure car simulation, like every wheel's slip and every wheel's grip being, you know, uh, calculated in real time and stuff like that. But the effect of this is actually pretty darn convincing and works really well. I have a video clip that I'll link to here of me demoing this on my Samsung Galaxy S2, which is an older generation Android device, so it runs really well even on an older phone. You're guaranteed that it'll run well on the newer one. So without further ado, this is the Unity project open right here. As a disclaimer right off the bat, I'm going to say that you can follow this tutorial for the 25 minutes or whatever it is, and you can pause the screen and look at the script in HD on there and kind of reproduce the script by typing it on your own and following the setup, and you can completely get through this tutorial just free and clear and all that. But if you want kind of a shortcut and you'd like access to this prefab and model and the script already completely written out for you, basically access to this entire Unity project, I'm going to put a PayPal link in the video description, and I'll probably overlay an annotation when I'm in the editing phase on YouTube, and it'll just link you over to my PayPal or whatever, and I think like maybe a donation of $5 or something like that, and I will directly send you this entire project. So what that does for you is it saves you typing out and copying the script off the screen, and gives you a 3D model and an editable PSD texture. And if anything, this model has a lot of branding on it from corporate companies, Ford, DeWalt. So you probably don't want to use it in a commercial project. But you could edit the PSD to completely remove the logo and the Fusion logo and all that, and just have a generic NASCAR car. And it's also, even if you're not making a NASCAR game, this is a great car and model to benchmark performance on your mobile games and stuff and say, well, this is a 500 try vehicle, and you cram as many of them on screen as you can driving, or use them as your AI, and then you can benchmark and say, well, it performs great with 20 AI at a 500 try vehicle, but not so great when I pull in another 2000 try vehicle or something like that. So it's also, if you acquire this project from me, it's also great to have the model for benchmarking purposes, even if it never actually sees it into production. So what you see in my scene now is just some ground. It's a large quad. I just went game object, create other quad, and looking for the transform node. I scaled it up like 600 by 600, and then I put a simple diffuse texture on it, an asphalt texture, seamless, and tiled it 55 by 55. And tiling just allows us to kind of stretch that texture way out over that large plane without it getting too blurry and too large. A directional light, and that's what's casting a little bit of light on the scene and the shadow. The main camera, which has a smooth follow script on it, okay, and that is not my script, that's Unity's. They just provide it for free in projects. And you go Assets, Import Package, Scripts, and underneath the camera scripts right here, there's 3 in there. We're missing the smooth follow one because it's already in my project, but I just uncheck them. Well, normally, okay, like that, and I just select the one I want, which was smooth follow, and I go Import. And it brought the smooth follow script in right there. And I keep a neat little hierarchy in here. Materials, models, prefab scenes. These are all folders that you can create by just right-clicking in here and going folder, and then name it something, you know, and then put your stuff in it and keep it nice and organized. So in the scripts folder, smooth follows in there and the player car. Smooth follow is just dragged onto the main camera like that, and then the player car, once you build it and put it in the scene, is dragged into the target. And then what I'll do is I'll just show you everything working. This is the car driving and the camera script following and all that jazz. So this car is pretty cool. I actually like it better than the wheel collider cars because it has this sliding and drifting, and if you watch it, it can donut, and then the grip catches up and it kind of snaps back into place. It has reverse. I know NASCAR cars don't have reverse, so that's kind of neat. But I love the drifting and the realistic sliding on it. And really, if you just want to think about it, it's very much like an ice cube sliding over a hockey rink, except you control it. So a lot of that too, we'll look on the prefab here. We're going to look at the script real quick and then I'll show it to you in detail. We have some of the max speed and the power, which is like the torque. We have grip, which is set kind of low now, and that's why you saw that slipping and sliding. And if we set it at something like 150 or 200, it won't slip and slide and drift that much. Turn speed is how fast the vehicle responds to turning, like really fast, or if it was a big truck, this would probably be like 1 or 2 or something like that. It would turn very slowly. My speed is not something you edit. It's actually just a readout for you to look at and say, hey, the car's going 50 miles an hour, 20 miles an hour. It's the same for throttle, actual grip, and horizontal. I just exposed these. They could be hidden in the inspector, but I just wanted you to be able to select the car, hit play, and then kind of look how it's working. You know, it's showing your speed. It's showing the horizontal input on the keyboard. I'm holding full left, so it says -1. And then I'll hold full right and it says +1. And then actual grip showing you like where the wheels are losing grip. See, it's reducing down to 30. Now my wheels don't have very much grip at all and the car slides horribly, you know, but at lower speeds, like this, the car keeps pretty good grip. And then you can see throttle too, like I have full throttle 1, full throttle all the way back -1. Those are supposed to be private variables and kind of hidden in the inspector away from you, but I expose them so that you can kind of debug and look at them. And I'll describe that in a little bit when we set this up. So I'm going to get rid of this prefab and we're going to build it, okay? As if you had your own model. So I have a folder called models and you would have your own 3D model in there, okay? I can go in here and I'm just going to, if you're using 3.5 or 3.7 Unity, you won't have some of these settings, but it's not really a big deal. Just don't import the animation on it. Or did I hit apply? Yes, I did. Okay. Well, because of my screen capture, it makes everything run a bit slower. Okay, to say the least. So we're not bringing any animation in on that. And so just bring your 3D model in over into the hierarchy view, and we can take a look at it. And it's you know, it's awesome. You like your model, you're happy with it. One important thing that I like to say is Unity, once we start embedding this model into parent transforms and things like that, and the model gets a lot of scripts on it, and it's embedded into other prefabs and stuff, the connection to the original model gets very wonky in Unity. And I don't know if you've noticed that. You'll go back into your 3D app and edit the model some more, like change a wheel size, and then you come back in and like the model doesn't update right. Like sometimes pieces of the model will be off in space, or it'll be super tiny like that, and it's just because nested prefabs and all that weird stuff, it just doesn't work right in Unity. So what I do is when I have my source model, it's pretty much done. You know, I can add things onto it later, like custom spoilers and other things, by saving out other models and dragging that other second model in the scene and lining it up to the original. But really, I don't want to be editing on this original model, and it's linked, it's blue, so it's linked back to the original model. So I'm going to select it. I'm going to go Game Object, Break Prefab Instance, and now it's grayed out. It's its own instance now. Whatever I do to it, this here will no longer, changes to this will no longer affect this, and vice versa. So it's like just a fresh model in Unity I can play with and use. So we want to start putting some I'm going to go over here and we're going to look at the prefab I created earlier, which is what we're going to end up with. And there's some components, the main components we need on the prefab we're going to create. You'll see we need a box collider, a rigid body, the player car script, and an audio source. And that's really the only things we need on this. I kept it really as about as simple as you could get for mobile. So I don't want to put all these things on the model directly. I want to put them on a parent object that will contain all of the data, and then my 3D model is kind of a child object in the hierarchy. It's just one part of the whole piece. So I'm going to go game object create empty. And I have some weird data on the transform, so I'm just going to go up to the little gear here and go reset. And that just puts it at 0, resets the scale, just cleans all the data up on that so it's a fresh little empty game object transform. And on my end, because I want my prefab to be called player, I'm going to type player, but you could call yours car1, player car, whatever. And that's going to be my root car object for the prefab. Okay? I'm going to drag the 3D model inside. So now I have my basically clean data on everything here from a player, and then the model stuff starts, and then all the model with all its different unique data. So kind of separates all of that data in the hierarchy from the model, from the root object. So what I'm going to do is you go in your empty prefabs folder if you have other prefabs that are unrelated, and I'm going to right click and do create new prefab, and I'm going to call it player. Ignore the old prefab I created earlier. It's just for us to reference. That was for me to test. Okay? And then I'm going to select our object we made here with the model inside of it. I'm going to drag it over into player prefab. Okay? Now I'm going to right click on this, scroll down, delete. So there is our player. It's a prefab. I'm going to drag it back in the scene. It's ready to go. It's connected. It's blue. It's connected back to the source prefab here. And we want it connected because we're going to make changes, and we're going to hit this little apply button, and it's going to update our changes back to the prefab in our entire project. Global asset in our project. So the three things we needed were, first we needed a box collider. We're going to go component, physics, box collider. I'm going to go in the top view, and I'm going to go wireframe mode. I'm going to click on the box collider, and we'll just scale it out, 2.5. Now how I'm doing this is when you hover over one of the X or Y's or whatever, it gives you those little arrows, and you can just hold down left mouse button and go left and right, and it'll let you scrub the values, which is really cool. I don't know if you can see my car anymore. To me, that's good enough. I'm happy with that. I'm going to hit apply, and it applies the box collider. Now we need to go into the side view. Okay, make sure you're in the orthographic view and not the perspective view. If you're in Unity 4.0 or 4.2, it has the two different modes. I think in 3.5 or 3.6, 3.56 Unity, it's just purely orthographic. You don't get a perspective ortho. But just go into the pure orthographic. And I'm going to go to the center value here for the box collider, and I'm going to move my box collider kind of centered up. And then I'm going to use the Y size, and I'm going to scale it up. And move the center back down a little. And the important part is the bottom of this collider right here is going to be what touches the ground and seats the car on the ground. So you want the wheels in it to be lined right up. That's where the wheel's going to touch the ground. That's where the box collider is going to touch the ground. To me, that looks pretty good. I'm happy. And then we'll go back into ortho view. Ortho view. And we'll take a look at it. It looks pretty good. The only issue I'm seeing is you can see that my box collider is in the ground slightly, and that is not good. So what we're going to do is just raise the car up just a little bit like that, up in here, and we'll go 0.05. You might not have that problem on your car, but it just needs to be making sure that it doesn't start in the ground, or else sometimes the two colliders will, when you hit the play button, will force each other out, and the car will explode out into the sky, and it's just not good. So we have our box collider component, okay, and it's sized properly around the vehicle. Looks good. So the next component that we want to add on is a rigid body. So we're going to go component, physics, and we're going to add the rigid body. And there it is. Okay. We want to set the mass for this around somewhere around 200. It could be different for your car depending on what's the physics are like in your world, the gravity in your world, the size of your vehicle, the scale. if you're using real world scale or not, but 200 seemed to work for me. Play with that number. It's just how heavy your vehicle is. The only other thing I'm going to change in here is interpolate. I'm going to set to interpolate. I'm going to have, excuse me, I had a late night. So I'm going to set interpolate to interpolate. So the rigid body's on and it's good to go. The other component that we need on is an audio source. So I'm going to go component audio. I'm going to add an audio source, and this is just for our engine sound alone. Okay, so play on awake is good. That means when you first hit play and start the scene up, it'll start playing immediately, which is good. The engine is running immediately. And then I want loop on because I want the engine sound to loop. And then we need an audio clip. It says it has none, so I conveniently have an engine sound, an audio clip in here called engine sound, and it is a looping sound, and I put it in a folder called sound, and it actually is completely seamless loop of just an engine idling or whatever. Where was I? So I applied that. I'm going to hit apply on the prefab, and we've applied our audio source. Now we have our collider, our rigid body, and our engine audio. The only thing we're missing now on this prefab is the script. Player car. So I'm going to drag it on, and we have our player car script. I'm going to hit apply. Now the script is applied to this prefab. Okay? So I'm going to reference back on my old created one because I had got good values for it. Power 1500. So 300 would be too low. Wouldn't even make the car move. All the other settings are good on this, and so I'm going to actually, we'll leave it just for future reference. So on the prefab we've been creating, we have all these slots here that say front left wheel, front right wheel, and it says none transform. Ooh, excuse my yawn again. Basically, this is saying I want to know where the wheels are, the actual transform component of the wheels. Okay, it needs to know because it wants to do some rotations on them, like where it rotates like this for acceleration, and when it rotates like this for steering. Good times, right? So it needs those plugged in. So pretty obviously, front left wheel, we can go left front wheel. Front right wheel would be right front wheel. Rear left wheel would be left rear. And rear right wheel would be rear right wheel. I'm going to hit apply. So this is why it's important when you're in your 3D modeling app or wherever you're creating your vehicle, name your wheels properly. Name the left front wheel, left front, left rear, blah, 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 so that you know where to plug those in the script later. Okay. So we have a unique case on the front wheels. Okay. They're not like the back wheels. The back wheels will only ever rotate like this. They don't turn. But the front wheels rotate like this, and they rotate like this on two different axes. So the problem becomes is if we just give one rotation command for both axes like that, you get these double transform data, double rotations, and the wheels act real funky. So what we have to do is we have to separate out part of the wheel that we want to rotate this way, and then we have to create empty nodes, empty game objects or transforms, which are going to be left front wheel transform and right wheel transform. We have to create those right now to basically put these wheels as child into those nodes, and then we'll rotate those nodes for the steering. So those transforms will steer the car, and then these actual wheels will be rotated like this. So what it does is it basically eliminates and separates the transform rotations on these and on these. So I'll explain that here in a sec. Let's just go create empty game object, create empty game object, shift select both. Let's hit our little gear and reset them both so their data is all zeroed out. Let's drag them down into the stock car. Okay, they're in the stock car, in your model. Let's call one left front wheel transform. Let's call the other right front wheel transform. Okay, so we have these containers. The only problem is this is literally these transforms right here that I'm moving that's invisible is literally they're what are going to rotate the wheels for its steering. So if it were to rotate from here in the middle of the car, we'd have a big problem. Our our wheel would go out here and rotate like this. Negative. We don't want that. We want it to rotate around its own axis. So basically, this transforms pivot needs to be exactly where this wheel's pivot is right here, pretty close. Okay? So let's grab the left front wheel one and let's take a look at our wheel, and you'll take a look at yours. And I'm going to remove the texture for a sec to get a better look at it, because I want to use that center point of the wheel right there to snap my transform to. So using Unity's built-in cool snapping, I hold down the V key with that selected, and then just drag over, and it snaps to that wheel. Okay? Awesome. So now it's snapped, but it's not entirely centered, which is easily solvable. We'll go back to the top, go in wireframe mode, and then orthographic top, and then we'll just move it over, and it's really easy to kind of eyeball it. I think 102 is good. Okay, and then we want to do the same thing with the right front wheel transform. Let's hold down the V key, snap it over to that center point so we know it's centered on the wheel. Okay, and then we'll go in the top view or whatever view you're comfortable with and just kind of put it in the middle there. And you know what? That looks pretty darn well centered to me, and that looks pretty darn well centered on that wheel to me. So let's go back to texture. Oh, by the way, File, Save Scene. Don't do too much work and then not save. It's horrible to lose stuff. So now that we have this parent transform, let's make the actual wheel child of that. So for the left front wheel transform, we're going to grab the left front wheel and drag it in. Yes, it's okay to break the prefab connection right now. Okay, let's look at right front wheel. Let's grab that. We'll child that in. So here's what happened. This is cool. We have this empty game object we created here, but now the wheel is controlled by it. Okay, so when I select that object and the wheel, the pivots are like in the identical spot. So that means they'll rotate around the same exact spot. So now I can get, look at that, good wheel rotation that way, good wheel rotation that way, off just the parent, without even manipulating the wheel itself. And that's the goal, is we need the steering to be manipulated on this transform, and then the acceleration to be manipulated on this transform. We had to separate them. So now we have what we needed for these two other slots. Left front wheel transform, right there, right front wheel transform. And then of course these are up here, front left up here, the actual wheel, that's going to just control the acceleration, like the movement of the wheel this way. Okay? And then this down here is going to control the steering. That resolves a lot of issues that some of the other car tutorials and stuff have with wheels being weird and wonky. So I'm going to hit apply and make sure our prefab's good to go. And honestly, we just built this, but I think it's ready to drive right out of the gate. Yep. There we go. And there you go. Drivable vehicle with really cool physics. I mean, especially for like a mobile game or something. I love it. I think it looks cool if you just look at it up in the... Oh! Let's see if we can't get a close look at the wheels in action. See, so they steer and they rotate properly. Very cool. And our camera is not following the car because we created this new prefab and didn't drag it in. Easy peasy, lemon squeezy, and now we follow it, and we have an unbelievably cool NASCAR car that we just created. So we just created that together or whatever, and you used your own model. So let me go in real quick. I'll take just a couple minutes, and we're going to go quick. This is not a tutorial to show you how to do scripting. I'm going to explain what some of the things in the script do just to help you edit it on your own. But it would take, you know, another 15 or 20 minutes to describe every single variable. I'm opening it in this script, you know, so we're not going to go super in depth on it because I want to keep this short. We're already at 25 minutes, and I would like to keep this under 30 minutes so YouTube doesn't complain to me about file size of the upload. It's not a very large script at all. But if you have never done scripting before or whatever, then yeah, it'll probably look a little crazy. But really, honestly, if you've done programming and scripting, like especially cars or something, you'll see that it's not complicated at all. So I've commented out with the green stuff, which is basically stuff that doesn't run in the script, and it just tells you what some important things are doing. Okay, this is the physics calculations here and all these. Private variable means it's something that you're not going to see in the inspector here. Okay, when it just has public variable in front of it, then it is something publicly you'll see here. Okay, private variables, almost always you're not editing those. Okay, they're, you could consider them read-only. I'm only looking at them to see what data they're returning, or the script is using the data from them for some other calculation. The ones that are set to public, like these rear wheel transforms here, are usually the ones where you need to drag something into the inspector and apply it. So as you can see, this is just a section where we're plugging in our wheels. This is where we plugged in the two parent containers for the front left and right wheels for the steering. Okay, this is a private var here, but you see that it has new transform for, it's an array containing transforms for the wheels. This is an internal thing where Unity's creating an array up here, and it's throwing in, later in the script, it's throwing in the wheels we applied into this array, these transforms. So let's look at some important stuff. Power's kind of important. It's adjustable in the inspector, and it's basically the torque or engine power of the car, how fast it can accelerate. Max speed is basically where it will cap out, and it won't travel any faster than that, 50 miles an hour, whatever. Car grip is basically how much it grips the pavement, how much it sticks to it. By default, it's pretty low. Go up to 200 if you want it to stick like a dime. Turn speed is how fast the car turns. Like if it was a big truck, it would turn slowly, so 1.0. A NASCAR car probably turns pretty sharp, so 3. Private var slide speed. Okay, it's private, so it's something you could look at. You could put public in front of it. Okay, we'll go back, wait for Unity to compile it, and then we'll look. And that private variable that we just changed to public, which was slide speed, now shows up here in the inspector. And we don't want to change it, but if we were to hit play and watch, it'll show us how much the car's sliding. See? Gives you a data value. So if you ever want to use that, a slide speed could be used. I can see one absolutely definite purpose for it is putting down some little trail renderers. Like, you guys know what trail renderers are, and use those to like render a little trail of tire tracks, and then grab these wheels and like parent the trail renderer inside of these back wheels or something. Okay, and then use the slide speed and say, like, by default, if the slide speed is 0, or let's hit play and see what its values are. If it's low, like 0 or negative value or something, then trail renderer disabled, enabled not true, equal not true. And then like if slide speed is greater than 20, like boom, like that, or greater than 12, then trail renderer enabled true. So basically what I just said to you is basically when that slide speed goes over that number, 15, 20, or 10, the trail renderers would turn on and you'd have skid marks. So it's a way to make like high-powered skid marks. Okay, so obviously you can see how we're going to go back and change it back to private. Sometimes it's interesting to use these built-in variables to make other functionality happen, i.e. slide speed could be used to measure the amount the car is slipping, and you could use that to turn a trail renderer on and off. Okay, my speed is another one. Can be used to turn a speedometer needle, or digitally cause a speedometer to go up. Use my speed and read it out to a GUI text or something. Other ones like car right, car forward, temp velocity, and all that, these private ones here, these are internal to the script calculations, and you're not really going to do any good reading them. They're using it to calculate the forces on the car when it's sliding and turns. So function start, we run a function called initialize. For people who don't know a lot about scripting, function start runs when the scene is boom. When you hit play, everything in function start happens. And we said, well, we want a command called initialize, or a function called command to happen. So it shoots down here and it says, oh, here's initialize, function initialize, and all this stuff happens. This is all stuff we don't want to be processing or happening in real time every frame. Okay, this is where the mobile optimizations come in. We want to cache a reference to all of this stuff. The cars transform. We don't want to be looking that up every frame of our game and slowing it down. So let's do it in the initialize when the scene first starts. Let's do that with our rigid body. Let's find the direction of up for the car so the script knows what up is. Let's find the rigid body's mass. How much did we just set that mass to? We set it to like 200. Let's cache the direction that's forward of the car, that Z direction down. Let's keep that in memory. Let's find the right, the vector 3 to the right. And then let's also set up the wheels first thing. When you hit play button, the wheels should be set up. So let's run a command called setup wheels, which we'll go down to in a second. Okay, and then here, this is an important part, and you can tweak in the script. Car rigid body, that's the rigid body on our car. It's center of mass. Okay, X, Y, and Z. So basically, let's describe this. It's in 3D space. Right now, you look at this box collider, and you see that pivot in the very center. Well, by default, that's where the center of mass for this car would be. It would be up in the middle of the car, not near the engine, not down near the bottom. And so it's likely that your car may flip over at high speeds or something like that. Usually, if you ever see cars in Unity tutorials flipping over, turning on their sides, it's the center of mass, where it's at on this rigid body, on the collider. So right here we tweak it and we say, all right, so in X, which is left and right, we want it pretty much in the center at 0, okay? In the Y, which is up and down, we want it -7. So we put that center of mass down here, somewhere right around here. And having it lower like that is not exactly 100% realistic, but it keeps your car from flipping over. It creates better physics. Okay, and then in Z, which is down towards the hood, we say go 0.35, which is just down towards the front of the hood, more towards the engine. So a lot of our physics are going to happen right up around here where the firewall would be, or the engine, the back of the engine. So realistically, that's where the weight center of the car may be. I'm not like a car guru or a mechanic, but it seems to work good. So that's what this does. If you want your center of mass or physics to behave a little bit differently, tweak these numbers. Make the center of mass a little lower below the car, or higher, or a little more further to the front. This value, 0.35, moving it more up the hood, changes how the back of the car kind of swings around when you're turning. So it can create some neat effects. Okay, function update for the uninitiated in scripting is a function that runs, it's an internal Unity function that runs every frame of your game. So if you're checking for like touches on the screen or presses on the keyboard, you need to check every single frame. Check input is my command for doing that. And car physics update. So let's make sure the physics in the car rolling and turning and steering are happening every frame. And let's make sure we're looking for touches and keyboard presses every frame. Okay, and then late update is a neat little function, another built-in Unity function, not my creation, that happens after update happens. So it's neat to kind of delay the way things happen. So we say, let's do the physics first, an update, and then let's rotate all our visual wheels. So this is a function or command that's going to actually do the turning of our 3D geometry. So our physics stuff is kind of separated from our geometry stuff. And then engine sound function is just a command to cause the engine RPMs to happen. So up here we had a command and initialize when the scene first started called setup wheels. So that screams down here. Okay, hold on a sec. If you want to start copying this script, now is a good time to pause it and take a look. And then pause it from here, and I'm going to scroll down a little bit more. I realized that I wasn't doing this properly. And then I'm going to stop there. And then we have, I was on setup wheels command here and initialize. So you can pause again here. I'm going to run down. That command will run down here and start this function called setup wheels. Basically, the if part is saying if null. It's running this whole everything in these brackets, and it's saying, all right, let's ask a question. So if front left wheel, front right wheel, rear left wheel, these are the transform slots, which are right here. All these slots for the transforms. Null means empty. So if it hasn't been plugged in, or you as the creator, game designer, did not plug these wheels into the slots, then debug log error, which is just a printout in Unity's console down here. This is where it'll print that message. It'll give you a warning that prints out this text that says, hey, you haven't applied all the wheel transforms in the car. And then after that, it'll stop the debug and stop printing that, and just it'll print it once. And then it says, all right, else if they're not null and like it's been plugged in properly, then let's go into our wheel transform array, which is that private var we didn't access, and let's grab each section of the array, 0, 1, 2, and 3, and 4, and let's apply those actual physical wheels that you as the game designer did plug in. So that's Unity doing an internal thing where it's plugging in references to the wheels. Okay, and that happens in start. That's not happening in every frame and update. That's cached up in start. When setup wheels is set here and initialize. Okay. Okay, so the next thing we have is just this private variable in the middle here, rotation amount. This is just a private variable you will not tweak that just describes in the 3 axes the rotations going on for the wheels. Okay, all of the wheels. Basically this rotation for the acceleration or forward movement of the car. Okay, so then we have function rotate visual wheels, which up here in late update, we wanted it to happen after the physics stuff, so we said late update. Okay, where do we go? Okay, rotate visual wheels. And then so we took those parent containers we made for the front wheels, front wheel visuals, rotation for steering the car, blah, blah, blah. And we're rotating local Euler angles y around y, which is this axis. Okay, and we're making that equal to horizontal times 30. All right, 30 is an arbitrary multiplier, which I just discovered was kind of a good number. You can experiment that and set that, and the wheels, if you set it lower, like 2020, when you turn and steer the car, they won't turn as far. You know, they may turn like that, whereas with 30, they may turn like that. So if you need your wheels to turn out further or turn less, tweak that number. Horizontal is just a variable that represents in our input. It just means left and right on the keyboard, A and D keys on the keyboard. Yeah, that's pretty much it. Or tilting an Android or iPhone device left and right, the tilt accelerometer or whatever. That's horizontal. So it's saying let's turn those wheels around their Euler angles times 30 and times the input of tilting a phone or pressing left and right on the keyboard. So it's steering for both front and right and left right wheels. And then on the rotation amount, which is this vector 3 up here, we just say, all right, do some math and calculations. Take the car's right vector, its relative velocity in z. This is why it facing down z was important. Z, everything on the car is facing down z this way. Okay, because it's measuring the velocity of the rigid body. How fast is that rigid body traveling? And it's saying, so let's multiply that times time. So it's frame rate independent. It happens actually based on time, not frame rate. And then multiply that with some math, which is radians to degrees. It's just converting the script rotational data to a actual Unity readable data. And basically, it's sending rotation amount back up here. And it's just to rotate the wheels, like I said, for forward movement, acceleration. Okay? And then all of these other ones are, these are all the wheels, okay? This isn't the steering, this is the acceleration. And it's just giving a rotate command times the rotation amount for all 4 wheels. Real simple. And then we have another private var here, which is device accelerometer sensitivity, and longest variable name ever in history. But it does what it says. It's how sensitive the mobile accelerometer will be. So you can crank that number up if you want the car to steer more based on smaller tilting of the device, or, you know, basically it's how sensitive the accelerometer is. So here's function input, check input, which we called up here in update. Okay, every frame we're looking, we need to check the input. So this is the cool stuff in function input right here, this whole command, that determines if this game is running on a Android phone, an iPhone, if it's running in the Windows editor, or if it's running in Windows web player. So, okay, so how it does this is, going to go through this kind of quick, we're running over time, but it's just saying if the application platform is an iPhone, or, these are or symbols, real important, or is the platform an Android phone, then let's set the acceleration to input acceleration times the sensitivity. All right, input acceleration is a built-in Unity thing for just basically pulling out the raw data for the device's accelerometer. Okay, so the raw data for that. Okay, And then we're saying basically if that data from the phone being tilted around X, if it's greater than the dead zone or if it's less than the dead zone, then the horizontal input equals that accelerometer data, which remember horizontal was left and right on the keyboard, and it was also the A and D keys. So we're just saying the device's accelerometer is equal to that now, so we can control that horizontal variable with that. The dead zone stuff is just, it's a variable up top. Let's find it. Where is it? Up here? Okay. It's a private var, but you can tweak that number. It's just saying, don't let the device turn the car if it's not past this value. Like what it does is it lets the accelerometer kind of sit at that value until you tilt it far enough that it exceeds this value or it's less than that value, and then the accelerometer will kick in. So it creates a dead zone, like a dead zone on a joystick where it's calibrated. Okay, that's what this part's doing. And then else it just says then zero out the horizontal, which means, hey, the car's not turning because you're not tilting. And then we just say, yeah, the throttle's zero too because we haven't recognized any touches or anything. And then this is built-in Unity scripting stuff. It just says for touch and input touches. That's just any touchscreen device's way of registering an array of all the possible fingers you could be touching on the screen at any place. Okay, then we have a little bit of simple code here, and this is the cool part. I have another video up that I'm going to put a little annotation in for you to just click on it and watch, where this project is running on an Android phone. Okay, and the way it works is if you touch the left lower third of the screen, it's brakes, and if you touch the lower right third of the screen, it's gas. You don't have to hit any specific buttons, just touch that area of the screen. And this is the code that does that. It just says if your touch position on X and if your touch position on Y, which is X is across, Y is down, is divided by a third of the screen, okay? So we're saying that third in X and Y, so it would be that little corner. Then we're saying that would be the lower right-hand corner of the screen. We're saying if you're touching in that area, throttle 1. That just means, boom, the car has full gas. Else if the touch position X is less than and the touch position Y is less than the third of the screen height and width, then throttle -1. So we're saying less than, it would be the left lower side of the screen, and we're saying, all right, negative throttle, let's back this car up and turn the brakes on. Okay, so this entire part right here is the if for iPhone and Android. These are all you need to control this car on a touch device. Then the else if down here, even simpler, is if you want to control it on a PC or a Mac. Else if application platform is Windows Editor, which is how we're able to play it right here in the editor like this. Okay, it determines immediately that the platform is the editor, and it says we can play it and use it. And then if it does determine that, everything in these brackets happens. It says, okay, well the horizontal now will equal the horizontal axis and the vertical axis, which by default in Unity's input manager is the left and right arrows, the up and down arrows, and the WASD keys. Standard controls for every game. We just say, all right, well if the application is the editor, or if it's the web player, which I just put in there by chance, then use these controls. Now this is important, so I'm going to show you this real quick in Unity's documentation. I'm going to bring this over. This is it, runtime platform. What I just copied and pasted out of here. No. Okay, and these are all the different runtime platforms that Unity supports. Now, if this car game that you're doing, I covered the iPhone, I covered Android, I covered the editor so you can test it, and I covered web player. But you might want to make a Windows player, which is basically making a standalone build on Windows. And you're going to want to copy that or put it over here. And then we need, let's see, if application platform, okay, we need a copy. Fact. Let's see if we got this right. Nope, we don't need that equals over here. Okay, so now I'm going to hit Control Save. It'll check and see, is this platform the editor? Is it the web player? Or is it a standalone player? Okay, so awesome. We have 3 different things. So you can go back in here and add cases by looking at the script reference for runtime platform and add cases like if this is a Flash player build, a 360 build, and so on and so forth. Okay, now I'm going to get ready to try to wrap this up. If it's any one of these platforms, use the keyboard keys, basically. Car physics update, I am not going to go into depth on this, but it's just a bunch of vector 3 data and manipulation of transforms and forces on the rigid body. These are all the car for physics stuff you don't want to mess with, nor do you need to even touch any of this stuff in here. Okay, the only number you may actually tweak is this turn velocity, and this is basically how fast the car turns, and it's basically all of the calculations are multiplied by 800. So sometimes if you cranked this up, the car would turn faster. Turn it down, it would turn slower. Okay? And you don't need to mess with any of these or any of this. This is actually just calculating the actual grip of the car, the speed of the car, and how to determine its sliding and the amount of grip it has based on speed. Okay? And then we have our function slow velocity for braking and reversing. And then we have function engine sound, which was called up in update earlier. And this just says, hey, take the audio, the pitch on the audio source, which is this pitch right here. Yep. Take that, and that is the engine sound too. So in function engine sound, we say audio pitch is just 0.30, okay, by default. So it's kind of a low idle. The pitch is kind of low if the car's sitting still. And add my speed to it, 0 to 50, and as my speed goes up, it ramps up. So the sound should ramp up, and then multiply it times this multiplier, okay? And then we say, all right, well, if my speed's getting faster, over 30, then shift a gear. It simulates the sound of a shift of gear. Lower the pitch a little bit, lower the speed that the gear changes at too, and so on and so forth for every amount of speed. Now you can tweak these numbers to get the gears to sound like they're shifting in different spots, and just experiment with this part. And then the last part here just says, if the audio pitch is greater than 2.0, then audio pitch equals 2, which basically is a redundant, sounds redundant, but it's just saying, hey, if this audio pitch goes over 2 because the car's speed's so great, then cap it at 2. Don't let it go over. Don't let it squeal in some crazy sound. And then fixed update is actually where a lot of the really important forces, when you press a key or touch the screen, pushing on the car, a literal add force is happening on the rigid body. This is where it's applying it to the sides of the rigid body for turning, and this is where it's applying it behind the rigid body for the engine to push it forward, or from the front of the car. Okay? And that's it. These are just the add force on rigid body commands for turning. And for grip, this is what simulates the grip, where it looks like the car sticking and sliding over the ground is actually this, which is a force on the side of the collider. So cool stuff in the script. Hopefully you're able to pause it and take a look at the entire script, and you can just copy this and really this script and those couple of components on this car, the audio source, the rigid body, and the box collider are really the only things you need, and that script typed out. And of course you need your own 3D model. But like I said, in the video description will be this entire project as you see it right here, with all these folders with the sound, the textures, the 3D model, the prefab, and the script already all typed out. Just there'll be a link in the video description and the annotation over it. Just hit me up with a small, like $5 PayPal donation, and I will send this entire project to you directly in your email. And then you can just immediately start playing with it and dropping your own models in. Or go around and type the script out and pull your own model in and set it up your own way. Either way, happy Unity game developing, and thank you.